Friday. I got 2 in there. That's it. Okay. All right. Do we want to copy this down, people? I would strongly recommend that. So you don't have to... Huh? Yes. Okay. Graphing. Let's look at this again. Okay, a little more in depth. Cole, you ready? If we have a graph of displacement and time, let's make it look like that one. What is the slope of that? What does the slope represent? What does it mean?
Speed.
I heard it from 3 people. I heard it wrong from 1 person.
Speed.
Speed or velocity. We don't really have a direction here. Because the line goes up, we're kind of saying that's positive, but speed's good enough, okay? Are you okay with the letter M from grade 10? Well, if you're not, that's what it means. Okay? The person who said acceleration, that was you. It's neither. Okay? Remember that. It's an easy mark on the test if you do. The slope of a displacement or position time graph is speed. What's the slope of a speed time graph? Yes, and it said that yesterday in the notes, but I didn't emphasize it, okay? But I did say, let's just look at the units. Slope, by definition, is rise over run. A lot of people are still kind of rusty with this stuff. You should kind of know it from grade 10, right? If I give you 2 coordinate points, how many more do you need to calculate the slope? That's it. That's all you need. 2 points, you plug it in, and you get the slope, okay? Just units. Now we got meaning. If the rise is in meters a second, and the run is in seconds, that's meters per second, which is units for acceleration. Yes, okay, and if that makes sense, great, and if not, memorize it. The slope of a speed time graph is acceleration. It's always going to be a constant line because we don't have changing acceleration in public school, not even in university. Okay? So, this I gave you yesterday. It's not another equation, it's the same one. But we're going to look at that in terms of a graph. Determining uniform acceleration. Here's a speed versus time graph. What's the slope of a speed versus time graph represent? Let's be Chinese. Everybody yell it out. What's the slope of a speed time graph?
Acceleration.
Oh, terrible Chinese class. Acceleration. Note the title. Y versus X. What's Y here? Speed. What's X? Time. Every line can be written as an equation like that. We want to make substitutions here. What is Y? I just said it. It's speed. Let's call it V for velocity. Is slope. What's X? Time. And what is my y-intercept? That's what that means, right? Well, have a look. What is it? It's 2. Okay? Let's calculate the slope, shall we? What could we possibly be talking about? It's more important than listening to this. Okay. Well, slope is rise over run. Let's find a couple of nice points. Here's one. Here's one. What's the rise? How much does it rise from here to here? 2. How much does it run from here to here? 0.6 seconds, 0.8 seconds, 0.2. Rise over run. I'm doing it right on the graph. Look at that. How many times does 2/10 go into 2? 10, good. What's the units? Meters per second per second. That's the slope, okay? Does it matter if you take it here and here? Well, they do it down here. Have a look. Do I get the same thing? Where is it? 1 times 10 to the 1. What the heck is that? That's also known as 10. Okay? It's the same line, like it goes up the same rate. It's got to have the same slope. I don't care what points you take it as. But remember, don't take your data points. Always use the line in a lab. Okay, so V is, what's M? 10. Okay, I'm not even going to put the units there. T plus 2. That's the relationship. That's the equation of this line. So let's have a look at this. You see that? VF is VO plus AT. Let's write this like this. Does that look familiar? Does that kind of look like the formula? Sure does. VF, that's like a final velocity V there. VO, is this the speed this thing starts at initially? Yeah, at time 0, this thing was already doing 2 meters a second. That's its initial speed. Acceleration, well, that's the slope of this line. There it is. It's 10. Time, well, that's just the time. Okay, that's the formula. It looks like the equation of that line, doesn't it? Same deal. So again, that's, we know, initial speed, or speed at t equals 0 in this case. Okay, that's final speed. You can calculate that for anything on here. You can find out its speed graphically. If we got to go maybe time 3.5 seconds, that's way off the graph. That's called extrapolation, and we can use the formula for that. Okay? So that's what's going on. Any questions? Let me give you one more example, because you're going to need it for the other question I'm going to give you from yesterday. So here's a nice place to put it, right here in the warm-up. Okay, example. A car accelerates from a stoplight. Is that useful information?
Yeah.
Sure is. 2, let's not trick you with any units here, 12 meters a second in 4 seconds. Now to make this easier, I'll split it up into A and B. In question number 2 from yesterday, which I haven't assigned yet, it doesn't do that. What is its acceleration? And B, how long will it take to reach a speed of 20 meters per second? Okay, the reason number 2 is tricky is it's 2 problems in one. This is 2 separate problems. Part A. Every question you should be doing this. And on the last question, if you noticed on that quiz, it was 2 marks. If all you had was a little bit of work in a formula, you might have got 1 out of 2 on it. Okay? So if you leave it blank, I'll guarantee you get 0 out of 2 every time. Okay, what do I know? Accelerates from a stoplight. What does that mean? From a stoplight. What is its initial speed? That's what that says. That's valuable information because there's an initial velocity in our formulas. Okay? VO0. 12 meters a second. What must that be? If I already have an initial speed, that must be the final speed. In 4 seconds, that's a time. A says, what's the acceleration? That's what I'm trying to find. Now, what formula do I want to use? And this will get awfully tricky in just a few short days, because there's lots of different formulas we can use for acceleration. 4, in fact. Okay, well, here's one. Does that look like I got it covered? Yeah. Okay, that's got A. Good. That's what I want to find. I got VO, I got VF, and I got T. Good. I can use that one. All right, so I got to go back over here. VF is 12 minus 0 over the time 4. What's my acceleration? 3 meters a second squared. Okay, so far so good? Because B, if I didn't get acceleration, I wouldn't be able to solve the problem, okay? Because I don't have enough information there. How long? Are we talking about time or are we talking about a distance? Yeah, it's time. And English is kind of tough there, right? B. I want to know how long, time. And I know it's hard to decipher whether that's a distance, longness or a time longness. Okay. Reach a speed of 20. What's that? Final. That's a different final than this one, isn't it? It's a new problem, guys. Okay? So don't use this 12 anymore. VF is 20. What's my initial? Well, I still started from a stoplight. Okay? It's constant acceleration. It's uniform. It has to be. Otherwise, we won't be able to solve anything. So VO is still 0. I know acceleration now is 3. That doesn't change. It's constant acceleration. Like I said, for the 5th time, every problem will be constant acceleration. Do you know what a change in acceleration is called? Jerk. I kid you not. J-E-R-K. Just like funny students. Okay? Here is the same formula. Only I have to solve that for what? T. Okay? So the shortcut is, without explaining the algebra, just swap those. T is VF minus VO over A. So that's 20 minus 0 over the time, sorry, acceleration now, 20 over 3, which is, I gotta go up here, not enough room, 6.7 seconds. Okay? Where's the answer there? There. Okay, so 2 problems in 1. So today, last day, number 2, good question. I wanted to give you that one first. Obviously finish up yesterday's, and page 56, number 1 and 2.